Ever wondered what the future holds for holographic technology? Let's delve into this captivating world of light and illusion. Holography, a method of producing three-dimensional images, has been a subject of fascination for many years. It's not just about projecting an image into thin air. Imagine a technology that can simulate entire three-dimensional environments as if they were real. Sounds like something straight out of Star Trek, doesn't it? Indeed, the concept of a holodeck from the popular science fiction series Star Trek has been a long-standing inspiration for scientists and innovators in the field of holography. In the series, the holodeck was a virtual reality space where the physical and visual properties of objects could be recreated. This idea of a room where people could interact with lifelike, computer-generated environments and characters has been a driving force in the pursuit of advanced holographic technology. However, the creation of dynamic three-dimensional holograms, much like those in the holodeck, remains largely in the realm of science fiction. There are significant challenges to overcome, such as the need for a series of two-dimensional images to be stacked without interfering with each other. This cross-interference, or crosstalk, has been a major roadblock in the development of 3D holographic projection. Despite these challenges, recent advancements in the field are promising. A team from Turkey has announced the successful projection of realistic 3D holograms that can be viewed from any angle. The team's technique has the potential to work in real time, bringing us a step closer to the dream of a simplified version of a holodeck. This is the dawn of a new era in holography. As we move forward, we can expect to see more innovations and improvements in optical projection technology, enhancing the way we interact with our surroundings. The projection of dynamic 3D holograms still seems like science fiction, yet there are promising advancements on the horizon. The future of holographic technology is indeed bright, and we're just at the beginning of this exciting journey. Now, let's dive into the development of holography over the years. The story of holography is a narrative of continuous innovation and technological advancement. Its inception can be traced back to the mid-20th century, when Hungarian-British physicist Denis Gabor first introduced the concept. His groundbreaking work, which earned him the Nobel Prize in Physics in 1971, laid the foundation for what would become a revolutionary field. Throughout the 70s and 80s, holography was primarily confined to the realm of scientific research and high-tech labs, but the turn of the 21st century witnessed a significant shift. As technology became more advanced, the widespread use of holography began to seem less like science fiction and more like an imminent reality. The early 2000s saw the rise of holography in popular culture, with its use in various movies and TV shows, most notably Star Trek's holodeck, fueling public interest and fascination. Behind the scenes, scientists and researchers were working tirelessly to make the magic of holography a reality. Fast forward to the 2010s, the development of holographic technology took a significant leap forward. A team from Turkey demonstrated the first realistic 3D holograms that could be viewed from any angle, not just a few. This was a game-changer, marking a major milestone in the journey of holography. The Turkish team's technique, which they believe can work in real time, has paved the way for dynamic 3D video holography. As Professor Gaith Maki from Bilkent University announced, soon it may be possible to create a simplified version of a holodeck. The present state of the art in holography is indeed impressive, with the potential to project up to 1,000 simultaneous images. This is a far cry from the initial projection of 3 to 4 images, showing just how far we've come. As we see, the journey of holography has been filled with exciting breakthroughs and innovations. Let us now turn our attention to one of the major challenges in holographic technology, the problem of crosstalk. Opening. One of the major challenges in holography is the issue of crosstalk. Let's dive into the science of holography a little deeper. The term crosstalk might seem out of place in this context, but it's actually a crucial piece of the holography puzzle. In the realm of 3D holography, crosstalk refers to the interference that occurs when a multitude of two-dimensional images are stacked together to create a three-dimensional hologram. Imagine trying to listen to a beautiful symphony, but all the instruments are playing at top volume, overlapping and drowning out each other. That's crosstalk in a nutshell. For years, the tech world has grappled with this issue. The traditional approach to mitigate crosstalk has been to improve the technology behind optical projection. Think of it as trying to fine-tune each instrument in our symphony so they can all play harmoniously together. This method focuses on enhancing the physical components involved in the process, refining them to a point where the interference is minimal. However, this approach has its limits. Despite continuous advancements in optical projection technology, the pesky problem of crosstalk persists. It's like an uninvited guest at a party, always showing up no matter how much you try to avoid it. This has left many in the field scratching their heads, wondering if there might be another way around this issue. And then, a team from Turkey decided to change the game. Instead of focusing on the physical components of the technology, they turned their attention to the mathematical aspects. They hypothesized that the root of the crosstalk problem might not lie in the hardware, but in the equations and algorithms that drive the technology. Closing. However, a team from Turkey has proposed a different solution to this problem. They believe that the answer to the crosstalk dilemma might just be hidden in the complex world of mathematics. And if they're right, they could be on the brink of a breakthrough that brings us one step closer to the reality of a Star Trek-like holodeck. This is where mathematics steps in to bring the holodeck closer to reality. In the world of 3D holography, the bane of the existence of many researchers is an issue known as crosstalk. This phenomenon of cross-interference occurs when the projection of multiple 2D images required to create a 3D hologram interferes with each other. For years, the common belief was that this was a limitation of optical projection technology. But a team from Turkey begs to differ, proposing an innovative solution rooted in the realm of mathematics. So, what's their take on this? They believe that the problem of crosstalk is not due to any deficiencies in the physical components of holography, but rather it's a mathematical issue. They argue that any pair of mutually random high-dimensional vectors tend to be orthogonal, meaning they are at right angles to each other. This is a result of two fundamental mathematical principles: the central limit theorem and the law of large numbers. Using this mathematical property, the team devised a simple but ingenious wavefront engineering trick. They added a random phase to each image, and voila, the issue of cross-interference was eliminated without the need for any additional optics. Let's break this down a bit. Imagine you're trying to project a 3D image of a cup. To do this, you would need to simultaneously project the rear, middle, and front parts of the cup. This was previously impossible due to crosstalk. But with this mathematical solution, the team was able to advance the state-of-the-art in projection from just 3 or 4 images to a staggering 1,000 simultaneous projections. This breakthrough is a game changer. It has pushed the boundaries of what was previously thought possible in holography. It has brought us one step closer to the realization of a holodeck-like environment where 3D holograms can be viewed from any angle, making the virtual seem almost tangible. This breakthrough has pushed the boundaries of what was previously thought possible in holography. With this new development, the future of holography looks brighter than ever. As we venture into the realm of the 21st century, the strides we are making in technology are nothing short of astounding. The breakthroughs we've seen in holography are a testament to this, and with this latest development, we are edging closer to a reality that once only existed in science fiction. The implications of this groundbreaking technology are far-reaching. It is not just about creating stunning visual displays, but about fundamentally changing how we interact with digital content. Imagine a world where we can project dynamic 3D videos, not just on our screens, but in our living rooms, offices, or classrooms. A world where we can engage with holographic interfaces in real time, just like in Star Trek's holodeck. This breakthrough could pave the way for dynamic 3D video holography, a technology that could revolutionize entertainment, education, and even scientific research. It could offer immersive experiences that surpass anything currently available, bringing fictional worlds to life or making remote locations accessible at the click of a button. Additionally, this development may lead to the creation of a simplified version of a holodeck, a virtual reality environment that simulates not only objects but entire 3D environments as if they were real. This could be a game changer in fields like architecture, interior design, and urban planning, where professionals could virtually walk through their designs before they are built. The future is indeed bright and full of exciting possibilities. However, it's important to remember that we are still at the beginning of this journey. The technology needs to be refined, and the practical applications need to be explored. But one thing is certain: we are on the cusp of a new era in holography, one that promises to reshape our relationship with technology. So keep an eye on this space, because the future of holography is full of exciting possibilities.